By the way, I've got a drama class outside making a lot of noise. Hi everyone, welcome back. If you want to support me, please press like and subscribe. Triangular prisms. I was going to hold up shapes and do all sorts of things about it, and I went, when you walk into an assessment, you don't have the shapes. You only have the diagram you can look at. And I went, no, I could use the shapes to give you a better understanding. But I found when I was talking to a lot of my students the other day, that they would understand a lot of this. Volume is quite the easy one. Surface area is the more difficult. Most people will get volume right. A lot of students will get surface area wrong. Let's have a look what's going on. I left it as inches because real life we often see inches in Australia. Even though we basically everything's in centimetres, a lot of things we get from overseas are in inches. Let's have a look what's going on. It's got this big part here that says the area of the end. If you look at most formula sheets, it'll just go AH. Usually with a capital, but not always. But they'll just go AH, which means the area of the end. Now I'm going to look at this shape and look what's going on. It's called a triangular prism. Triangular prism because it's got a triangle at this end and it's got the same size triangle at this end. I can shade it, and often I will do that, and my students will go, yeah, and I'll go, you've got that triangle there, and you've got this triangle here. And you go, oh, they're the same size. Well, this is also, by the way, so that little right angle that's there, that's still the right angle there. And then you talk about, okay, how do we get the area of a triangle? Most people are okay, and they'll go, it's half the base times the height. Some people I know will put half AB. Doesn't matter which way you do it, you can use the different letters. Now I'm going to nag about, for a triangle, the base and the height must meet in right angles, not this height. So what I call the big height. The base times the height. See why people get confused with it. Those two numbers there meet in right angles. I'm not going to use the 5 because it doesn't meet there in right angles and it doesn't meet there in right angles. So it's good if you can shade both ends, I've found over the years, and then you can go, well, okay, I've got there's the base and there's the height that meet in right angles. So it doesn't matter if you do it, that's the base and that's the height, or that's the base and that's the height, either way. Let's look at the formula. You've got a half times the base. I'm going to call 3 the base, and I'm going to call 4 the height. Now that's for the triangle. Now we need this capital H, the big H, and all that is the distance between the two triangles. I'm not going to write it that way. The distance between the two triangles. So if you're looking at this triangle here, you're looking at this triangle here, the distance between them is 9. If you wanted to, you could write 9s all over the place. The distance between the two triangles is 9. So we're going to multiply that by 9. Now all you have to do is put that in your calculator and write the answer down. If you're confident with it, I look at this and I go half of 4 is 2. I go 2, 3, 6 and 6 9s are 54. You don't have to do that. We're talking about volume, remember? And volume, we're talking about inches. So I put inches with a little cubed above it. Little 3 to say that we're using volume. 3 means we're using volume, volume means 3. Okay, so what are we doing? The area of this end, or that end, doesn't matter which one you use, times by the distance between them. That's all that formula is. I'm going to come over this one here because it looks different before I go to surface area. So for the volume of this one, I'm going to shade this triangle there because we're talking about a triangular prism. So let's look at the formula again. We've got half little base times little height times the big height. Now what are the base and the height? The two numbers that meet in right angles. But before I do that, I probably should shade this as well. The trouble is they start to crisscross over each other and that confuses some people. But it depends what the question is you get in the test. I'm going to look at this bottom one here. Because it's got this number. Oh, we need that number there. And people get confused and they go, what numbers do I use? And what do I keep talking about? The two numbers that meet in. What do I talk about? The two numbers that meet in right angles. You go, oh, wait a minute, I don't know what the two numbers are that meet in right angles. I've got this one across here is 6.6. And I need this one across here. Now sometimes people need to shade that in and go, okay, that one there is the same as that one there, which is 10. So my triangle's actually got a 6.6 and a 10. And that's what mucks people up big time. Let's have a look at it. You go half times the base, and this one, that's the base of the triangle, and then the height of the triangle is that one there. That's not meaning there. That's 6.6 across there. And then we're going to multiply it by the height, and the height is the distance between the two triangles. And most people can look at it and say, there's the triangle there, there's the triangle there, and there's the distance between them. And the distance between them is called the height. So that's our height, which is 6. So you put in your calculator, left to right, you can type that as 0.5 if you want to, type it as a half, any way you want to. And the answer to that is 198. Talking about volume again, talking about centimetres, so we're talking about centimetres cubed. Now the big one, surface area. No matter what we do, you've got to look at the 5 shapes. There's no way around it. And now triangular prism, I've got a triangle this end, and I've got a triangle that end. So if I have a look at it, that's going to be 2 lots of a half times the base times the height. Now there's people here that I know that are watching this video who won't want to go base and height, they want to go A and B, or just multiply the 2 numbers. So let's have a look at what that is. Before I do the rest, I already know the base of that triangle is 3, and the height of that triangle is 4. So I've got 2 lots of that triangle now, the big one, the 3 rectangles. So I'm going to do 3 calculations. It's really hard to say to people, just here's a shortcut, and this is a quick way of doing it. I'm going to have a look at what's going on here. This big rectangle at the front here, you can see it's a 9 times a 5. So if I had that one was a 9 times a 5. Then there's a rectangle here on the bottom, if your brain can see what it is, and that's a 3 times a 9. So that 9 there is the same as that 9 there is the same as that 9 there. So we've got a 3 times 9. And then there's one more. So we've done the big one. I'm going to trace my fingers around it. There's that one there. There's this one here. And there's this skinny one over the back here. So I can see that's got a 4 and it's got a 9. So that's a 4 times 9. And you put it in your calculator and write the answer down. But I'm going to write that as 45. I'm going to write that as 27. I'm going to write that as 36. So you put it in your calculator, go left to right, you put that as 0.5, if you want to put it as half, doesn't matter. And you get an answer of 120. Remember we're talking about inches, and we're talking about area, and area we're talking about square, not cube. So 120, that looks a bit weird, 120 inches squared. And inches, a shortcut is just on the end. So I could go through this fairly quick if people are okay with it. Let's look at the triangle. It's 2 lots of the half the base times the height. I'm going to do that separate again. So I've got 2 times a half. You've got to figure out the base and the height. A lot of people jump in and they think that's the base of that triangle, but we don't know the height there. We only know the height sideways. So it's been turned around to trick people to see if they can muck up on how to get the question. So on that triangle, there's the base, which is 10, and the height is 6.6. Now the 3 rectangles. Oh my goodness, here we go. Here's an obvious one. I trace my fingers around that, my finger around that one. I've got a 7 times a 7. So the interesting part is the end's actually a square. So that's a 7 times a 7. What's going to happen with the others? This one's pretty obvious. If I go along there, it's like a funny skinny shape that's going through there. And you can see it's got a 10 and a 7. So that's easy. I've got a 10 and a 7. And over the other side here, I've got another one that looks the same as that one. So they've actually made an isosceles triangle. So this one's a 10, and if that's 7 over there, that's 7 over there. I've had students over the years who I've had, they prefer to write all the numbers on. So if that's a 10, that's a 10. If that's a 7, that's a 7. Can get confusing for some people, and it gets too cluttered. So just to finish this one up, it's a 10 times 7, so it's another 10 times 7. And when I put that in my calculator, the interesting part is 2 times a half is just 1. So I've actually got 10 by 6.6, that's a 66. All you have to do though is put it in your calculator here in most schools in Western Australia. Now I could do that in my head. Yeah, could do. If you're watching me do it, that's 140. And I look at that and I go, that's 115. And I can add those two together, 115 over 100. And I've got 5, I've got 5, I've got 2. It's not too bad to do by hand.